Good morning, one and all. Today, I'm starting the location of your substations and rating of your distribution substations. Okay, how we will locate the substation, which type of area that will be selected for that location of the substation, and how the ratings of the substation will be decided, that all will be discussed in present class. Okay, in the previous class, we already discussing about the what is meant by the substations and what are the classifications are there in the case of a substation, and which what are the components that will be used in the substations. Okay, that all will be discussed in the previous class. Okay, now in the present class we are discussing about the how we will locate the substations. Okay, the voltage levels and voltage regulation considerations, the voltage levels and voltage regulation considerations, sub-transmission cost and substation cost, the cost of the primary feeders, mains and distribution transformers dedicates the locations of the substations. Okay, the distribution transformers, feeders and substation cost and the land cost, that all will be considered for the location of the substations. For the substations, the following rules should be considered. Okay, first one is the location of the substations as much as feasible closer to the load centers. Okay, it will be closer to the load centers and also it's the service area, so that the addition of the load time and the distance from the substation is minimized. Okay, the selection and the location of a site for the substations are having the following points. Okay, in that first one is the type of a substation. Which type of substation we will be located? First, we will decide which type of substation is to be located. Okay, the category of the substation is important for its location. Which type of substation is located, that is very important for that location. Okay, for example, a step-up substation, which is generally a point where the power from the various sources, that is generating missions or generating stations, is pulled and step up for a long distance transmissions. Okay, should be located as close to the generating stations as possible to minimize the transmission losses. Okay, suppose we are installing the step up substation. Okay, step up substation means that generally we are having the generating missions and the generating stations for the various power sources. Okay, for step up of that long distance transmissions, we should be located or near to the generating stations. Therefore, we minimize the transmission losses. Okay, therefore we minimize the transmission losses. Okay, understand first substation mana install cheyali ante adi ఏ type of substation అనేది మనం select చేసుకోవాలి. Which type of substation is to be installed? Okay, for example, we are installing the step-up substation. Step-up substation means that we are using the step-up transformers. Okay, therefore, this will be located at the near to the generating stations. Why? Because it is near to the generating stations, we are minimizing the transmission losses. We are minimizing the transmission losses. Okay, Similarly, we are selecting the step-down substations, or we are locating the step-down substations. Okay, this type of substation is to be located near to the load centers. Okay, why? Because it is near to the load centers means that reduce the transmission losses and cost of distribution systems and the better reliability of the supply. Cost of the distribution systems and the better reliability of the supply. Okay, that's why first of all we decide the which type of substation we should be located. Okay, on the basis of the type of the substation, the place will be decided. Okay, for example, we are taking the step-up substation that will be near to the generating stations for reducing or minimizing the transmission losses. And also we are taking the another example, that is step down substation. Okay, that is step down substation that should be located near the load centers. Why? Because it is near to the load centers means it reduces the transmission losses. Okay, reduce the transmission losses. Okay, the cost of the distribution system is also better. Okay, this is the one type of a substation, step up and the step down substations. Second one, the availability of a suitable and sufficient land. ఓకే, మనం ప్లేస్ పర్టికులర్ ప్లేస్ అనేది మనం డిసైడ్ అయిన తర్వాత ఆ ప్లేస్ అనేది మనకి అవైలబుల్ గా ఉందా లేదా, లేదా సూటబుల్ అవుతుందా లేదా అనేది ఫస్ట్ మనం సెలెక్ట్ చేసుకోవాలి. ఓకే, ద ల్యాండ్ ప్రపోజెస్ ఫర్ ద సబ్స్టేషన్ should be normally level and open for all the sides. Okay, that land will be open for all the sides. Okay, it should not be waterlogged, particularly in the rainy seasons. Okay, first of all we observe the water will be stopped at that land or the area, then the substation various equipments have to be damaged quickly. Okay, that's why it should not be logged particularly in the rainy seasons. Okay, therefore the site selected for a substation should be such that approach of transmission lines and their takeoff can be easily possible without any obstructions. Okay, suppose we are installing the 400 kilovolt substations. The area required for that substations is the 50 acres. Okay, suppose we are installing the 220 kilovolt substation, the area required for that is the 25 acres. Okay, suppose we are installing the 132 kilovolt substation, the area required is the 10 acres. Okay, that's why first we are selecting the site, and also this site is available or this site is suitable for that installing of that substations or not, that all will be observed. Okay, this is the second one. Next, third one is the communication facilities. Okay, suitable communication facility is desirable at a proposed substations, both during and the after its construction. Okay, after the construction and also during the construction we require some suitable communications facilities. Okay, it is better therefore to select the site along the side and existing the road to facilities and easier and cheaper transportation. Okay, it is near to the load centers or not, that all will be checked. Okay, next, atmospheric pollutions. Okay, next one is the atmospheric pollutions. Atmospheric pollutions, atmosphere around the factories. Okay, we observe the around the factories and which may produce the metal cordoning gases, air forms and conductivity dust, etc. And near to the sea coasts where air may be or more humidity and maybe salt land is detrimental to the proper running of the power systems. Okay, that's why we are first observing the polluted atmospheric pollution is suitable for that substation or not, that all will be observed. Okay, the location of the substations as much as the feasible closer to the load centers, and its selection must be provided for the proper voltage regulations which can be obtained without taking the extensive measures. Okay, without taking the extensive measures we select that area. Next one is the availability of essential amenities to the staff. Okay, while working in the substations, this is available for that staff utilities, that is example schools, hospitals, drinking waters, housing and etc. Okay, that is available for that station or not, that all will be checked for that land. Okay, next, drainage facilities. Okay, the site selected for the proposed substation should have the proper drainage arrangement or possibility of making the effective drainage arrangements to avoid the pollution of the air and growth of microorganisms, determination to equipments and the health conditions. Okay, these are all the following factors are to be considered for the selection or location of the substation. Okay, before going to installing the substation, various factors that are will be observed for the selection of a site for that substations. Why? Because we are considering the various factors for the selection of that substation means that the substation area is suitable and for all the considerations like for extension purpose and also the forecasting purpose and also the uh, and also we are observing the any effects are to be done for that load centers or the particular populated areas that all will be observed while selecting the location of that particular substations. Okay, these are the various points or these are the various steps for the selection of that substations. Okay, its selection must be provided for the proper access for incoming substation lines and the outgoing primary feeders. Okay, there is a availability of that feeder lines and the outgoing feeders are there, and if any problems that will be obtained for that incoming and the outgoing feeders, that all will be observed. Okay, it should be provide enough space for the future substation expansions. Okay, it should be provide enough space for the future extension. Okay, that are all the points that will be considered in the case of a selection of the substations. Okay, in the case of a selection of the substations, we are considering the different points for the consideration of that substations. Okay, it should be provide enough space for the future extension also. Okay, it should help to minimize the number of customers affected by the service outages. Okay, these are all the following considerations for the selection of the site for that substations. Okay, in that mainly we are observing the which type of a substation that will be located, that is example, for example, step up substation or the step down substations, and also availability of suitable and sufficient land is there for the future extension and also the forecasting purpose. Okay, that's all will be observed. Suppose we are installing the 400 kilowatt substations. In that case, we have the availability of the space is 50 acres. Suppose we are installing the 220 kilovolts, 25 acres and 132 kilovolts, 10 acres. Okay, this is the assumpted area for the installation of the these types of substations. Okay, depending upon the voltage ranges, the land will be decided. Okay, depending upon the voltage or rating of that substation, how much area that will be required, that all will be decided. Okay, next coming to the communication facilities and atmospheric pollutions and also availability of essentials of drinking water, housing, hospitals and schoolings for that staff and also the workers in the substations. Okay, that all will be observed while selecting the land for that substations. And also the drainage facilities will also be observed for the selection of that substations is the major important considerations for the pollution. Avoiding the pollutions of the air and the growth of microorganisms. Okay, these are the various factors for that should be observed while selecting the location of that substations. Okay, these are the various factors for selection of that and the location of that substations. Okay, first of all, what is meant by substations? Substation means a group of equipments that will be designed for the step up or step down or conversion, AC to DC conversion and frequency changes. Okay, that all the equipments are to be installed together to each other is called as the substations. Okay, normally we are having the different types of substations are there that will be depending upon the service construction and depending upon the constructional features. Okay, that will be divided into various types. And also we are observing the so many equipments are there in the case of a substation, that is like transformers, generators, circuit breakers, isolators, lightning arresters, switches, etc. That all will be used in the case of the substations. And next one is the how we will locate the substation land or the land for that substations. Okay, while considering the land for the substations, we are observing the different considerations that has to be, it is near to the load centers or not, and how much distance is there from that substation to the load centers, and also the proper voltage regulations is there, and also the most provide the incoming and outgoing substations of transmission line feeders is available or not, and also we are observing the enough space for the future extension or the forecasting of the substations is available or not, and also we are observing the minimizing the number of customers affected by the service outages, and also the some facilities are there in the for that land, that all will be observed for the selection of a particular substations. Okay, that substations, that selection will be depending upon the rating of the substations and also the type of a substation. Okay, that all the parameters will be depending upon the rating of the substations and also the type of the substations. Okay, these are the various points that will be considered while selecting the site for the substations. Next topic is the rating of a distribution substations. How we will decide the ratings of a distribution of the substations. Okay, the rating of a distribution substation depends upon the load density of the service area. Okay, in that service area, how much amount of load is there, and how and what is the load density is there in the particular area, that will be calculated, or that is depending upon the rating of the distribution systems. Okay, with increases in the load density, okay, with increases in the load density, the additional load requirements can be met either the service area of the given distribution substation maintaining constant and increasing its ratings, or installing no distribution substations. Okay, we definitely considering the forecasting of the substation is the major important consideration. Why? Because of the forecasting is the major important consideration. In the day by day, the population will be increases. Due to that increases in the population, definitely we are selecting the forecasting for the substations. Okay, forecasting means the how we will increase the rating of that substations. Okay, the rating of that substations will be depending upon the following considerations. Either the service area of the given distribution substation, or installing the new another substations. Okay, that will be decided, and therefore maintaining the capacity of the given substations. Okay, it is the helpful to consider the system changes. For short-term distribution planning, the load density is constant. For in the case of a short-term planning, the load density is the constant. Okay, but in the case of a long-term planning, the load density is increasing. Okay, the load density is increasing. Okay, therefore, for simplifies the gradually to analyze a square space area, for simplifying that analyzation, we are increasing the, we are analyzing the square shape area representing a part of our entire service area. Okay, suppose we are assuming we are taking the one square shape area, consider a square shape area served by four primary feeders. Consider a square shape area that will be served by the 4 primary feeders. Forms a central feed points. Forms a central feed points. Okay, these are the various points that will be considered for deciding the rating of the substations. Why? Because the rating will be changed, means that day by day the population will also be increases. Due to increases in the population, and we are reaching the load densities. For that, increasing the populations, we are requiring the additional rating of that substations. Okay, that will be depending upon the either service area of that substation or installing the new substations. Okay, that will be decided for the load density. Okay, that will be decided for the load density. Okay, that all considerations will be explained by taking the one rectangular area that will be fed by the 4 primary feeders. Considering a one rectangular area that will be fed by the 4 feeders. Okay, this is the rating of a distribution systems. Okay, the rating of the distribution substation depending upon the load density of the service area. With increases in the load density, the road requirements cannot be meet. Okay, that will be meet by using the depending upon the service area or installing a new distribution substations. Okay, it is helpful for the considerations of that changes, that is the short term change or the long term planning. Okay, in the short term planning, the load density is constant. In the long term planning, this will be increases, which simplifies greatly analysis of a square shaped systems. Okay, that will be explained with the one rectangular square shaped system. Okay, that will be explained with the one rectangular square shaped system. This is the rectangular square shaped system. Okay, this is the rectangular square shaped system. This rectangular substations will be fed by the 4 different feeders. Okay, this is the feeder 1 and this is the feeder 2 and this is the feeder 3 and this is the feeder 4. Okay, this is the distributed locations. Okay, these are all the distributed locations. These dots are indicated by the laterals or the load points. Okay, these dots are indicated by the laterals or the load points. Okay, this dark line indicates the feeder. Okay, this dark line indicates the feeder. Okay, while selecting the considerations for that distribution of substations, we are considering the different criteria. Okay, that is either by service area or by installing the new substations, either by increasing the service area or we are installing the new substations. Okay, that are the 2 points that will be considered for the selection of that substations. Okay, it is helpful to consider that the system changes, that is the short term and the long term planning. Okay, that all will be simplified by using a squared area. Okay, that square area is served by 4 primary feeders form a central feed point. Okay, that square area is served by a 4 primary feeders formed by a central feeding. Okay, that will be as shown in the figure. Okay, this is the central feeding. At that central feeding, 4 feeder lines are there that will be served by these 4 feeder lines. Okay, this is the feeder line 1, feeder line 2, feeder line 3 and feeder line 4. Okay, at the central of the service area. Okay, that will be observed by the central of that feeder area. Okay, consider a square wave square area served by a 4 primary feeders form a central feed point. Okay, this is the central feed point. Okay, this feeding point will be served by the 4 different feeder lines. Okay, this feeding point will be served by the 4 different feeding points. Okay, 4 different feeding points. First, in which each feeder and its substations feeders are of 3-phase circuit. Okay, in that each feeder and its substation feeders are of 3-phase circuit. Okay, therefore the percentage voltage drop from the feeder point F to the end of the feeder point H, from the feeder point F to the end of the feeder point H. Okay, this is the end of the feeder point, that is the H. From the feeder point F to the end of the feeder point H, the substation or the voltage drops from the feeder point F to the H. Therefore, percentage of voltage drop VDFH. Okay, this is the feeder point F at the center to the ending point, that is the H. Therefore, percentage VDFH, percentage voltage drop VD, FH is equal to FG plus GH. Voltage drop between F to G to voltage drop between G to H. Okay, voltage drop between F to G to voltage drop between G to H. Okay, this is the square area. Okay, this is the triangular area that will be considered for the calculation purpose. Okay, this small area will be considering for taking the calculation purpose. Okay, this is that small area that will be considered for taking the calculation purpose. Only this area we are taking for that calculation purpose. Next, okay, this is the overall voltage drop. Percentage VDF is equal to percentage of VDFG plus percentage of VDGH. Okay, this is the equation number 1. Next, from the figure, each feeder supplies a total load. Okay, therefore S is the total load. How many feeders are there? We are having the 4 feeders. Okay, therefore S4 is equal to total area means the A4. Total area means the A4 and D is the demand for that area. D is the load demand or the load density for that area. Therefore, S4 is equal to the A4 into D. Okay, therefore S4 is equal to the A4 into D. Okay, this is the power, particular power for each feeder supplies. Okay, how many feeders are there that will be supplied by the 4 feeders, and area is the A4 and D. Okay, that is units are the kVAs, kilovolt amperes. In that, A4 is the area supplied by one of feeder. A4 is the area supplied by one of 4 feeders. Okay, one of 4 feeders energizing from the load center point F. That is the center point, that is F. And D is the load density. D is the load density. And S4 is the total load supplied for that each feeder. Total load supplied for that each feeder. Okay, that is S4. Next, for a square shape area, the equation 2 can be modified as. Okay, this is the equation number 2. Okay, this is equation number 2. Okay, we are taking as the square shape area, then that equation is modified as, therefore A4 is equal to the L4. Okay, instead of A4 square, we are taking as the L4 square. A4 is equal to L4 square. Therefore, S4 is equal to L4 square into D. Okay, therefore S4 is equal to L4 square into D kVA. For non-uniform distribution load, the percentage voltage drop in the main feeder is given by, for non-uniform distributions of load, the percentage of voltage distribution is given by percentage of VD4. Percentage of VD4 equal to 2 by 3 L4 CS4. 2 by 3 L4 CS4. Okay, where C is the percentage of VD. It depends on the voltage and the conductor size. Okay, next substituting equation 3 in 4. Okay, S4. Equation 3 is the S4. S4 is equal to L4 square into D. S4 is equal to L4 square into D. Okay, substitute that S4 in the equation number 4. Okay, instead of S4, we are taking the L4 square into D. Therefore, L4 square into L4 is the L4 cube. L4 cube C into D. Okay, therefore, VD4 is equal to 2 by 3 L4 cube CD. 2 by 3 L4 cube CD. Okay, for the above equations, okay, this is the equation for the total voltage drop that will be considered in the case of a 4 feeders fitting. Okay, this is the calculation for that this particular area. Okay, calculation for this particular area. Okay, then from the above equation, it can be concluded that the total is located at a point and the main feeder at a distance of 2 by 3 L4, at a distance of 2 by 3 L4 from the feeding point. Okay, this is the particular point, that is the 2 by 3 L4 from the feeding point F. Okay, this is the total voltage drop at a particular 2 by 3 of L4 from the distribution point. Okay, this is the rating of a distribution substations. Rating of a distribution substation. While considering the rating of a distribution substations, we are considering the 2 points. First one is the సర్వీస్ రేటింగ్ మనం ఇంక్రీజ్ చేసుకోవాలి అంటే ఆ సర్వీస్ ఏరియా అనేది మనకి సఫిషియెంట్ గా ఉందా. ఓకే, ద సర్వీస్ ఏరియా ఆఫ్ గివెన్ డిస్ట్రిబ్యూషన్ సిస్టమ్స్ ఈజ్ మెయింటైన్ కాన్స్టెంట్స్ ఆర్ మనం ఇంక్రీజ్ చేసుకోవచ్చా లేదా అది కాన్స్టెంట్ గా ఉందా లేదా చూసుకోవాలి. ఒకవేళ మనకి అది కాన్స్టెంట్ గా ఉంటే నెక్స్ట్ క్రైటీరియా ఏంటి, వీఆర్ యాడింగ్ ద అనదర్ సబ్స్టేషన్ ఆర్ ద నియర్ టు దట్ సబ్స్టేషన్. ఓకే, ఆ సబ్స్టేషన్ కి నియర్ గా మనం ఏం చేయాలి, ఇంకొక సబ్స్టేషన్ అనే దాన్ని మనం యాడ్ చేసుకోవాలా లేదా అనేది మనం కన్స్ట్రక్ట్ చేసుకోవాలి. ఓకే, రేటింగ్ అనేది మనం డిసైడ్ చేసుకున్నప్పుడు లోడ్ డెన్సిటీ ఇంక్రీజ్ అవుతున్న కొద్దీ దాని రేటింగ్ అనేది సబ్స్టేషన్ కి మనం ఇంక్రీజ్ చేసుకుంటూ వెళ్ళాలి. ఓకే, అలా లోడ్ డెన్సిటీని మనం ఇంక్రీజ్ చేయాలి అంటే అడిషనల్ లోడ్స్ అనేవి మనం యాడ్ చేసుకోవాలి. అడిషనల్ లోడ్స్ మనం యాడ్ చేయాలి అంటే మనకున్న సర్వీస్ ఏరియా అనేది కరెక్ట్ గా మనకి సఫిషియెంట్ గా ఇంక్రీజ్ చేయగలమా లేదా అనేది ఫస్ట్ చూసుకోవాలి. ఒకవేళ మనం ఇంక్రీజ్ చేయలేము అన్నప్పుడు ఇంకొక సబ్స్టేషన్, న్యూ సబ్స్టేషన్ అనేది మనం అక్కడ యాడ్ చేయగలమా లేదా అనేది మనం ఫస్ట్ కన్స్ట్రక్ట్ చేసుకోవాలి. ఓకే, ఇలా చేసినప్పుడు మనకి ఏమేం పాయింట్స్ కన్స్ట్రక్ట్ చేసుకుంటాము అంటే అది షార్ట్ టర్మ్ కే మనం ఈ లోడ్ డెన్సిటీ ఇంక్రీజ్ అయిందా లేదా లాంగ్ టర్మ్ లో మనకి లోడ్ అనేది ఇంక్రీజ్ అవుతుందా ఫస్ట్ మనం అబ్జర్వ్ చేసుకోవాలి. షార్ట్ టర్మ్ కనుకోండి ఇంకొక సబ్స్టేషన్ మనం ఇంక్రీజ్ చేయాలి అంటే చాలా డిఫికల్ట్ ప్రాసెస్. అదే లాంగ్ టర్మ్ ప్లానింగ్ ఉంది అనుకోండి అప్పుడు మనం కంపల్సరీగా ఇంకో సబ్స్టేషన్ అయినా ఇంక్రీజ్ చేసుకోవచ్చు లేదా ఎన్ని ఎక్విప్మెంట్స్ అయినా మనం యాడ్ చేసుకోవచ్చు. ఓకే, ఇలా పాయింట్స్, వేరియస్ పాయింట్స్ మనం సెలెక్ట్ చేసుకుంటూ దాన్ని ఇంక్రీజ్ చేయాలి. ఓకే, ఇట్ సింప్లిఫైస్ ద గ్రేటెస్ట్ అనాలిసిస్. ఓకే, ఇలా సింప్లిఫికేషన్ కోసం మనం ఏం చేస్తున్నాము అంటే ఒక స్క్వేర్డ్ ఏరియా అనేది తీసుకున్నాము. ఓకే, ఈ స్క్వేర్డ్ ఏరియాలో మనం ఫీడర్ పాయింట్, ఫీడింగ్ పాయింట్ సెంటర్ నుంచి 4 ఫీడర్స్ తో మనం ఫీడింగ్ అనేది ఇస్తున్నాం. ఈ పర్టికులర్ ఏరియాకి సెంటర్ పాయింట్ నుంచి 4 ఫీడర్స్ తో మనం ఫీడింగ్ అనేది ఇస్తున్నాం. ఓకే, అలా 4 ఫీడర్స్ తో ఫీడింగ్ ఇచ్చినప్పుడు పర్టికులర్ ఏరియా ఒకదాన్ని మనం దీన్ని సెలెక్ట్ చేసుకొని ఈ పర్టికులర్ ఏరియాలో FGH అనే ఏరియాలో మనకి ఎంత వోల్టేజ్ డ్రాప్ ఉంది పర్టికులర్ ఏరియాలో అనేది క్యాలిక్యులేట్ చేయాలి. ఓకే, ఎంత వోల్టేజ్ డ్రాప్ ఉంది? VD4 ఈక్వల్ టు 2/3 L4³ CD అనే వోల్టేజ్ డ్రాప్ ఉంది. వేర్ D ఇస్ ద డెన్సిటీ. అందులో C వచ్చి కండక్టర్ సైజ్ ఆర్ పర్సంటేజ్ ఆఫ్ వోల్టేజ్ డ్రాప్ దట్ విల్ బి డిపెండింగ్ అపాన్ ద కండక్టర్ సైజ్. ఓకే, కండక్టర్ సైజ్ మీద ఆ వోల్టేజ్ డ్రాప్ అనేది మనకి డిపెండెంట్. అలా మనం పవర్ ని, డెన్సిటీని, వోల్టేజ్ డ్రాప్ ని క్యాలిక్యులేట్ చేస్తున్నాం. ఫస్ట్ ఆ F నుంచి H వరకు ఎంత వోల్టేజ్ డ్రాప్ ఉందో క్యాలిక్యులేట్ చేసాం. పర్సంటేజ్ VDFH ఈక్వల్ టు పర్సంటేజ్ VDFG ప్లస్ percentage VDGH. Okay, this is put equation number 1. Next we calculate the total power, that is S4. Particular area into load density. S4 is equal to A4 into load density ga manam calculate chestunnam. A4 ante area supplied by the 4 feeders. D is the load density. Okay, that is the power. Next a square shape area lo equation 2 ni malli modify cheskunnamo. A place lo mana L4 square తీసుకున్నాం. ఓకే, సో L4 స్క్వేర్ తీసుకొని పవర్ కి ఫార్ములా రాసుకున్నాం. S4 ఈక్వల్ టు L4 స్క్వేర్ ఇంటూ D. ఓకే, ఫర్ నాన్ యూనిఫామ్ డిస్ట్రిబ్యూషన్ కోసం మళ్ళీ ఏం చేస్తున్నాము అంటే ఈ వోల్టేజ్ డ్రాప్ ఈక్వేషన్ ని మనం ఈ percentage of VD4 ని 2/3 V4 CS4 గా కన్సిడర్ చేసుకున్నాం. ఓకే, దిస్ ఇస్ ద ఫిక్స్డ్ ఫార్ములా. ఓకే, ఇందులో మనం S4 ఏదైతే ఉందో దాన్ని సబ్స్టిట్యూట్ చేసుకోవాలి. ఏది S4 ఇన్ ఈక్వేషన్ నెంబర్ 3. ఓకే, therefore 3 in 4 రాసినప్పుడు టోటల్ VD4 ఎంత వస్తది? ఓకే, దట్ ఈస్ ద టోటల్ వోల్టేజ్ డ్రాప్ అట్ ఏ పర్టికులర్ స్క్వేర్ ఏరియా. ఈ పర్టికులర్ రెక్టాంగులర్ స్మాల్ ఏరియాకి ఎంత వోల్టేజ్ డ్రాప్ వచ్చింది అంటే 2/3 L4³ CD. 2/3 L4³ CD అనే వోల్టేజ్ డ్రాప్ ని మనం కన్స్ట్రక్ట్ చేసుకున్నాం. ఓకే, దిస్ ఈస్ ద ఈక్వేషన్ ఫర్ ద that can be concluded that the total load is located at a point on the main feeder at a distance for 2/3 L4 from the feeder point F. Okay, this is the selection for that rating of a distribution substations. Next class